Hi, this is Margo. This is Sunday evening, July the 24th, 2022. I hope everyone is safe and doing as well as possible. This will be my weekly update that I'll be putting on YouTube, and I hope everyone had a good week, or as good a week as they could. I'm kind of suffering. Had a kind of a rough week, but we've got stuff to go through here, so I'm gonna try and get through this show. I may have to cut it a little short. So I'd like to welcome everyone to the show tonight. I'm getting a really late start. It's just the way it is. I feel like I'm in an alternate universe or something. It's anyway, I'm here. So I'm gonna lead off the show tonight with this is Sam Carana's latest blog post from arcticnews.blogspot.com. It was put up yesterday, the 23rd, and he titles it Arctic Sea Ice July 2022, and he starts out by discussing what a blue ocean event is. And so I'll leave a link below so that everyone can go look at this, but this is an important article. It's got lots of important information about the Arctic and explains it in great detail. Blue ocean event. A blue ocean event occurs when virtually all sea ice disappears and the surface color changes from white, sea ice, to blue, or ocean. According to many, a blue ocean event starts once Arctic sea ice extent falls below 1 million square kilometers. The image on the right shows a trend pointing at zero Arctic sea ice volume by September of 2027. So here's his chart and showing the downward trend here on the sea ice. Note that the volume data in the image are averages for the month September. The minimum for each year is even lower. Furthermore, since zero volume implies zero extent, this indicates that a blue ocean event or extent below 1 million square kilometers could happen well before 2027. That's what we've been thinking too. And then sea ice concentration. Now, remember, extent is how far out the ice is spread, and they count everything in extent, even if there's a lot of open water or just wispy thin ice. They count all of that in extent. Now, volume is counted differently. It's the thickness. The thickness is included in volume. And then concentration is different. Concentration is like how much ice is in a certain area. So let's move on here. Another measure than sea ice extent or volume is sea ice concentration. The image below, adapted from University of Bremen, shows sea ice concentration on July 22nd, 2022, with concentration in many areas close to the North Pole down to zero, and yeah, it's shocking when we look at NASA Worldview. It is shocking to see all of the open water, and there's pieces of ice, big pieces, but a lot of open water, and it's down. Here's the North Pole, and there's this area coming straight down, and even out to the east there, where it's very poor concentration. Here's a picture. NASA Worldview satellite images below give a good idea of how much sea ice is still present in the Arctic, or how little, especially north of the North Pole. So this is from the 22nd, and both of these are from the 22nd. And so you can see all that dark area, that's open water. The ice is in terrible shape. And then this is from the U.S. Navy. Okay, 1 month animation below shows Arctic sea ice thickness up to July 16th, 2022, with 8 days of forecasts added. And it ends, the model ends for the 24th, which is today. And I'm a little upset with the Navy website. They have not updated their Arctic sea ice. They haven't updated it. The latest update was on the 17th. So anyway, so there we are today at the end there. The above animation shows a dramatic fall in sea ice thickness over a large area. I've been showing that. This fall in thickness is mostly due to warm water from the Atlantic Ocean that is melting the sea ice hanging underneath the surface. This is where the sea ice constitutes the latent heat buffer, consuming incoming heat in the process of melting. And here, from the University of Bremen, combination image below shows the difference in sea ice thickness between June 1st, here on the left, June 30th, and then July 22nd. So, huge changes there, you can see. And you can see the extent is being whittled in too. The images at the center and on the right show large areas where sea ice is less than 20 centimeters thick, indicating that the latent heat buffer had already disappeared in June, as also discussed further below. Here's from NASA Worldview. Combination image below shows the sea ice north of Greenland on June 19th and on July 19th and July 22nd, that even at places where the sea ice once was the thickest, it can melt away rapidly. The mechanism behind this is that as thick ice breaks off and fragments, it additionally gets heated up from the sides and thus further accelerates the melting as the sea ice breaks up further into even smaller pieces. And also, what happens is the ice drift pulls the ice away from the coastline, and when that happens, the ice gets jostled around and that thicker ice gets folded in underneath. That's what I've noticed. And then we go into ocean heat. On July 19th, the sea surface was as warm as 1.8 C or 35.2 Fahrenheit north of Greenland, as nullschool.net image below shows. We're seeing all these greens. The above image also shows how cold water blue flows down to the east of Greenland, while warm water green flows off the west coast of Norway toward the Arctic Ocean, diving under the sea ice north of Svalbard and reaching areas north of Greenland where sea surface temperatures rise above freezing point. Of the extra heat from Earth's energy imbalance, about 93% ends up in the ocean as increasing ocean heat content. 3% goes into melting ice, 4% goes into raising temperatures of land and melting permafrost, and less than 1% remains in the atmosphere. And there's that chart where you can see it's just going up. Sea ice has disappeared in the Bering Strait. Yeah, that's been ice-free for a while now. In part due to warm water from rivers in Alaska, as illustrated by the NOAA image below, which shows sea surface temperatures as high as 18.6 degrees Celsius or 65.48 degrees Fahrenheit. So this is Alaska, this is Russia, and right here is the Bering Strait there. And then this is Earth Null School. On July 19th, the sea surface temperature anomaly from 1981 to 2011 in the Arctic Ocean was as high as 14 C or 25.2 C Fahrenheit at the green circle. And the green circle is right here, where my pointer is. In 1981 to 2011, the sea surface temperature at this spot, at the green circle in the Kara Sea, at this time of year was around freezing point. So it's a little hard to see with all these lines. This is Greenland, but here's Norway, and this is Novaya Zemlya. So next to Novaya Zemlya, the above image also shows a distorted jet stream. Yeah, it's just loops now. Moving over the Arctic Ocean instead of circumventing the Arctic and thus keeping heat out of the Arctic and keep it cold inside the Arctic as it used to be, but that broke. and showing all these loops. See, it's jet loops. It's not streaming anymore. Here, the above NOAA image illustrates how the Gulf Stream is pushing warm water towards the Arctic, with sea surface temperatures in the North Atlantic reaching as high as 32.2 C, or 89.96 Fahrenheit on July 20th. So here it's in the red-orange, here in the Gulf of Mexico, and then that warm water's coming up. Okay, latent heat. Latent heat is heat that is less and less going into melting the sea ice. The reason this heat is called latent or hidden heat is that it doesn't raise the temperature of the water, but instead gets consumed in the process of melting the ice. Latent heat is energy associated with a phase change, such as the energy consumed when solid ice turns into water or melting. During a phase change, the temperature remains constant. Sea ice acts as a buffer that absorbs heat while keeping the temperature at 0 degrees Celsius. As long as there is sea ice in the water, this sea ice will keep absorbing heat, so the temperature doesn't rise at the sea surface. The amount of energy absorbed by melting ice is as much as it takes to heat an equivalent mass of water from 0 to 80 degrees Celsius. And so that's where we're at now, with so much open water in between the pieces of ice is the latent heat. And then here was a 2019 analysis of sea surface temperatures, and it's quite long. Anyway, 3 kinds of warming in the Arctic. Emissions, soot, snow and ice demise, and Arctic methane stores weaken. So we can see all these feedback loops, and we're in the middle of all of them. And we've seen this. Here's where we're losing the buffer of the thick ice, where it extends below the surface of the water. And so since 2012 it's been thin, but it's getting thinner. And let's read the conclusion here. Sorry. In conclusion, temperatures could rise strongly in the Arctic soon due to sea ice loss in combination with an upcoming El Niño and a peak in sunspots within the potential to drive humans extinct as early as 2025. While temperatures would continue to skyrocket in 2026, making it in many respects rather futile to speculate about what will happen beyond 2026. At the same time, the right thing to do now is to help avoid the worst things from happening through comprehensive and effective action as described in the climate plan. So, as far as I can tell, we're just headed off the cliff. So, thank you, Sam Carana, for that update on the sea ice and keeping on with your work. So here we're going to start on Climate Reanalyzer just to give an overview. Here are the maximum temperatures for today, and you can see this dark green in the Arctic. That's around 5°C. And we have all of this is above freezing. See, it's with the but 5 to even 10°C out here. See where it goes from the dark green up. And these whites, this is most of these temperatures that are in the white are going to be above 100 degrees Fahrenheit. So we can see it coming up from Mexico through Texas and up through the middle of the country. We have some whites on the east side from South Carolina up through North Carolina, Virginia, and then in the west as well. And we've got whites from Spain up into France, across Africa, and all the way over here in Kazakhstan. Also whites over the Tibetan Plateau, which is, I think that's unusual. And then 2-meter temperature anomaly. We've got browns coming from Russia all the way across this Kara Sea and over to Greenland, and then in this Canadian archipelago area we've got reddish browns. This is air temperature, and because we have jet loops, you can see the cold air where it's swooping down right next to the warmer air. Let's see. Worldwide, we're up 0.4°C higher than normal. The northern hemisphere is up 0.7°C. The Arctic is up 0.9°C. The Antarctic is down 0.8°C. Southern hemisphere is up 0.2°C. And the tropics are up 0.3°C higher than normal. Here's precipitation and clouds. The green is rain. We've had rain in the Baffin Bay this week. A lot of melting at Greenland. It spiked. I mean, it hit. It could. I don't know if it was an all-time high on the melt, but that happened this week. And we've got rain here over the Beaufort Sea and around Alaska and up here in northern Canada, also here in the Kara Sea and across Russia. Here's the flat view. And then the jet loops here can see the big loops, and this is where that cold air is escaping, coming down. Also on this, on the side where Russia is. And here in the southern hemisphere, it's got 3 loops all at once. This causes weather chaos. We'll look at sea ice and snow cover in a second. This is sea surface temperature anomaly as of Thursday. Now, I think they need to change this chart because it only goes up to 6C higher than normal. And we know it was higher than that from the Sam Carana report. But that's the highest this chart goes right now. We can see that's the light pink, and almost all of that kerosene is in the light pink. And then red in the Barents Sea, and brown all around Svalbard, and so on. We've got brown in the North Baffin Bay. Here in the Latent Sea, this has melted really fast this week. And we've got reds going into pinks here, and here in the Chukchi Sea we've got browns, and so on. Now, I'm very concerned about this area around Kamchatka, Russia. We can see pinks here in the Sea of Okhotsk, pinks and reds, and it's spreading down further south. And then we've got reds on the east side all the way down beside Japan, and then pinks up there. And I'm thinking that this could be from them dumping the extra radioactive material into the ocean from Fukushima. They had stored up a whole bunch but decided to dump it. I don't know if that's what's causing this so hot up here or what. And then we've got our blob here in the North Pacific that's reds and browns and pinks. Mediterranean is a lot of reds and browns there, and so on. Worldwide and the North Atlantic are up 0.4C higher than normal. Northern Hemisphere is up 0.6C. The North Pacific is up 0.7C. Southern Hemisphere is up 0.2C. And the Equatorial Pacific is down 0.2C. And that's this blue area. Equatorial Pacific. So there's that. Now, we'll move on to methane. I have 2 days worth of NOAA data to share, and then we'll look at methane on cams for Saturday. So we're going to do Friday and Saturday for NOAA. Here we are on Friday the 22nd in the morning. This is the MET-OP-B or MET-OP-1 satellite, and we're tracking the 469 millibar, which is about halfway up in the atmosphere. The mean or average was 1931 parts per billion, so we're seeing higher readings here this week, and the high reading was 2399. And in the afternoon, look at all this missing data. All of South America is missing, most of Africa, and most of Europe all of Europe and UK and part of Norway. So even with all that missing data, we were at 1929 for the mean here. The high reading was 2426. And then for yesterday, the 23rd in the morning, again, we have a lot of missing data, a lot of Africa and Middle East and Russia, and these are some areas with some really high readings. And then the Pacific Ocean is missing, and Alaska. Even with the missing data, this mean is at 1933, and that's the highest this number has been this year. And the high reading is 2337. And in the afternoon, the mean was 1931, and the high reading was 2375. Here's the chart and spreadsheet that I'm working off of. So for the 23rd, we averaged out to be 1932 parts per billion. That gives us an increase this week of 3 parts per billion, and the week before we went up 2.5. So here's our blue line, just going up now. And we're 10 parts per billion higher than we were a year ago. We're 62.5 parts per billion higher than when I started charting this on March the 1st of 2019. Now, when we look at the other summers, we saw a steeper rise earlier in the season. This year has been a slow rise. It's been going up, but it's been slower. But I think it's going to be pretty steep now. And we usually top out in our methane in around October, sometime in October. But we got kind of a late start on the increase here this year, but I don't think it's going to disappoint us with breaking all the records. And I mean, we're breaking records every day, and you have to remember that you know, when I say 10 parts per billion higher than a year ago, that's, I mean, we're breaking records. This is the highest it's been for this time of year. Okay, here I'll show you what we did this week. Here we were in our show last Sunday. We were at 1929. And then Monday it went up half a part per billion. On Tuesday it went down 1. Wednesday it went down 1. Thursday it jumped up 2. Friday it went up 1. Saturday it went down 0.5. And I mean Friday. And then Saturday, I don't know, I got mixed up on my days there, you get the idea. Saturday, it went up 2 parts per billion. So that was a pretty good jump from the day before. Give us an overall increase this week of 3 parts per billion. And we're 10 parts per billion higher than a year ago. Okay, now we'll go through CAMS. This is Copernicus Atmosphere Monitoring Services. They're out of the EU. And I have Saturday the 23rd up, Arctic view, and surface level ready. Here's our color ledger. So, this is still just billowing out of control. Here it comes some mollets. And, see, it's kind of spinning around. And we can see higher readings here. Now look at it where it moves out from the coastline. Now this is in the forecast period. Watch here from Russia and Norway. Watch, here it comes. See the wave move out. That's high methane. You see those waves move out over the coastline like that. And here in the interior of Russia, we've got higher methane. No, the fires have spread out across Russia. The Alaska fires, I haven't seen any smoke on cams for a while now from Alaska. I'm thinking they might have gotten enough rain to put the fires out. We're still seeing high readings in the interior. Here's Canada. That's at the tar sands. There's North Dakota. And here's our problem spot. Here, percolating in the North Atlantic. And so, we have higher readings all across the Arctic. So the methane is coming up through the sea ice. If there's ice there, and if there's not ice, it's just coming up. The water, you already saw how much the water is heated up. So you can just expect high methane readings where the water has already warmed up. Now we'll go to the North Pole view. Here we can see the northern hemisphere. And we still have high readings at the UK and Ireland. Earlier this week it was much worse. It was just a big black blob from Ireland over to Germany. This whole area, including the North Sea, was just a big blob. So here's Germany, and so on. Here's the Persian Gulf. See, that's filling up. Here's India. Here's China. And see how these high readings are spilling over the coastline. That's a sign of very high. See it streaming out. And then here in North America, in the US, the usual blobby places. Alright, now we're going to hop down to the Antarctic. Look at this. This darker blue, that's 1840 parts per billion, and you can see that goes away in the forecast period, so that now the main background color in the southern hemisphere has jumped up now to 1860. See, the whole thing is 1860 after Sunday. And so we've got greens streaming down off of Australia. So that's a dark green. See the dark green there? That's 1920. And that dark green. Now we'll look at the global view. And here's Australia. You can see certain areas are coming to life with methane. South America down here in Brazil. Now here, right around the equator, we're seeing the lower reading, the 1840. See, and here in the Indian Ocean. Our white spot is back here in China. See where my pointer is? That's near Beijing. And when it's white, that's above the highest reading on the chart. So that's above 10,000 parts per billion. Okay, now we'll go to 500 HPA. I've been having some trouble loading up this website. It won't load the images right off the bat. I have to play around with it. I don't know why that is. That just started this week. Here you are at 500 HPA. Here's the heaviest. See, it's over Japan and out over the Pacific Ocean and over India, and here over the Persian Gulf, and here in northern Russia, and over the Kara Sea, and so on. And notice that there's just one little spot of green, solid green, down here south of the equator. Well, one little spot here in the Pacific too. But the main background color in the southern hemisphere is now this yellow-green. So you can see that overall methane is going up around the whole planet, not just one little place. Okay, here's total column. That looks pretty bad. From Japan over into China, and then look at all of northern India, and then Persian Gulf over into Saudi Arabia. Then the red coming all the way across Africa and part of the Atlantic. Okay, so we're gonna go through these few pictures left. So here's the smoke from today. This is on cams. Here's the Arctic view. This is Russia. And we can see in southern Russia on the coastline, on this eastern coastline, lots of smoke. So that's where the fire is. And then the smoke is kind of, there's an arm that got caught up. It's coming over the Latent Sea and the Kara Sea. And then over here, see, Alaska's free and clear. The archipelago is free and clear. Greenland is free and clear. And we've got some smoke across Canada here. Here's sulfur dioxide today. Here it is at 500 HPA. So we have a little bit of a higher reading here. That's in Turkey. I don't know what that's from. This is from Popocatépetl, Mexico. Nothing just too dramatic though. And here's the ozone hole over the Antarctic, and the whole interior is in the thin zone. Even this yellow green. The solid yellow is 300 Dobson units, so all of this is below that. And we've got aqua here over the Weddell Sea. Here's the Arctic ozone. We can see it's opening up here over Russia. This is from methane and from the smoke. High methane readings will break down the ozone, as well as the smoke will break it down. So we've got a large area over here in Russia, and here next to the Latent Sea, and then coming down and across. And we got a thinning here at the North Pole and all the way down to Greenland. Here's the global view, and here's the aqua. This is in the Indian Ocean, and so on. And I just took a couple of earthquake pictures today. We had 179 today. There were 2 earthquakes here on Iceland, and then one near the Wandafuka Plate. We've got just a couple of 5s, 3 5s, 4 5s, I think. And then the rest are under that. Here's Iceland, and see this red line? That's the tectonic plate line. It goes right through the middle of the island, and you can see these are stacked up together. One was a 4.4 that came in at 6:23 this morning Pacific time, and then a 4.8 came in at 6:45, so 2 minutes later. And this is at Akureyri, Iceland. And then we're jumping over to the west coast of California and Oregon. This is the Wandafuka Plate that's kind of zigzagged. And so this earthquake is not on the plate, it's just to the west of it, and it was a 4.0, and they're just calling it off the coast of Oregon. And that came in today at 2:22 this morning. That's all of those. Now we'll move on to sea ice. We'll start off with our Climate Reanalyzer slideshow. So this is sea ice and snow cover. This is for today. And we're still seeing a little wisp along the southern coast of the Hudson Bay and a little bit on this coast of Canada here in the Baffin Bay. And then here's the darker areas showing less concentration. So this coincides with what we saw on Sam Carana from the Bremen Institute. Also here in the Beaufort Sea and the Chukchi Sea, see that's coming apart real fast. And here we were last Sunday, the 17th. We'll see what kind of differences there were. Here's Monday. So here on Monday, here's a big decrease on this east side. Could have been raining that day. Here's Tuesday, Wednesday, and here where it started pulling apart and opening up. This is in quadrant 3. Look at this. Here's Thursday, and I checked all the other models and I couldn't find a hole. So I think that might have been a mistake. Anyway, showing a hole here in quadrant 4 just above Ellesmere Island, but I kind of don't believe that. And here's Friday, how it's magically closed back up. And here's Saturday. And see the gray. So that's all of that. Okay, now we'll head on over to NASA Worldview. Oh, I forgot. I've still got other things to show. Sorry. Okay, so we saw this the 17th. This was last Sunday. So just imagine the amount of melting that's gone on this week. We're going to see a lot of open water, even right around the North Pole. And the ice is pulled away from Greenland. So here's their 30-day animation that the data, the forecast goes out only to next Sunday. Which is this Sunday, the 24th. Now, so if you can imagine that last Sunday there was almost no green, that the green had just gone away almost instantly, and almost no reds or yellows. Just imagine that, and then imagine how much more it's melted this week. And it's still whittling down to where the thickest ice is right in between. It's in between. So it's about 85 degrees north latitude. Now here they updated the Beaufort sea ice thickness, and this is for today, and see the whitish areas, that's open water. Here's the 30-day animation. And this goes out, the forecast goes out to next Sunday. So they updated this, and they updated a lot of the other views too, but not the Arctic sea ice. I mean thickness, for whatever reason. And you would think, with it being in the height of the melt season, they would be on this. You would think. So, okay. So we saw that. And see, they even updated the Antarctic. And here we are today with sea ice thickness in the Antarctic. We can see blues coming in here in the Ross Sea. The extent edges are creeping out just a tiny bit. Here's the 30-day animation. See, all of these are updated. And this goes out. How far does this go out? Oh, this was only updated to today, the 24th. So there's that. Now, this is National Snow and Ice Data Center. This is sea ice concentration, and where you see all the blues, that's where it's coming apart. And so here's the North Pole. So it's really all around the North Pole and up here. And here's the Arctic sea ice extent chart. The blue line is this year, the dotted line is 2012. And we can see it's still going pretty parallel to 2012. Here's the Antarctic, and here's the extent, and the blue line is this year, the green line is last year, and so it's slowing. I think this is slowing. Here's Greenland ice melt. This is as of yesterday. They've had huge areas melting all at once in the last few days. And here are the cumulative melt days for this year. Now the white is where they haven't recorded any ice loss. Here's the melt extent chart. And so here's our spike. It spiked up here at 42% a few days ago. And it hasn't come down that far. We're right around 30% right now, and it's been holding right around 30 for the last few days. And we can see we're well above the median, which is this blue dotted line. And traditionally, this would have reached the midpoint around the 1st of July, but no, our midpoint hit here this week. I mean, not midpoint, the high reading. And that's all of that. I'm so tired all of a sudden. Okay, now we're gonna jump to NASA Worldview, and we're tracking this A76 iceberg. It's actually in the sun right here, under the sunlight there. Here's the tippy point of the Western Peninsula, and here with nighttime layer, we can see him right here. He's rotating to the left, and there's just a little bit of ice that's standing in his way. So let's go back to last Sunday, and we'll see what it's done. Now see, last Sunday it was right in here. So here was Monday. It made a big move to the left there. Here's Tuesday's under a cloud. Wednesday, it's almost parallel. Okay, here's the 21st, 22nd, 23rd. Now see how it's rotating around to the left. And here we are today, and it's almost in line, parallel with like these grid lines. So there's that. Okay, let's go on up to the Arctic and take a look around. So here we are today. The smoke is down here in southeast Russia, and some smoke up here from the Latent Sea and across the Kara Sea here. And we'll turn on our sea ice concentration. Uh-oh, wrong one. Sorry. I'm very tired. I started early gathering all my data, but I just don't feel that good. So here we are today with sea ice concentration, and see these yellows. Wherever you see colors, that's where it's melting. This Chukchi Sea and Beaufort Sea, they're both in high melt. Also these tributaries, which make up the Northwest Passage, they're in very high melt. And what's left here in the Baffin Bay is in high melt as well. And you can see that this whole Latent Sea along the coastline has all opened up now. That just happened this week. And the Kara Sea is open. And see this opening between Severnaya Zemlya and Taimyr Peninsula, that's open. Not much ice left in the North Kara Sea at all. Alright, let's go back to last Sunday. Here we were last Sunday, and we saw the semicircle of the melting coming down here. That was last Sunday. So let's just click through. Here we go. Here's Monday. And so this is worse. There's a big hole right there. Here's Tuesday. Wednesday. Look at that. Thursday. Friday. Saturday. And then here we are today. And we'll turn off those layers. And now we'll go in looking at the satellite view. Look at this. This is the nearest strait. Now we've got some clouds here, but see all this open water. This ice is flowing down through here. This is an exit point for the sea ice, one of them. Here's Greenland. Here's the top edge. And this is the area Sam Carana showed. And we've got some wispy clouds here, but you can see where it's open. And then if we come up towards the North Pole, and we've got a lot of clouds today, but here this is open water. See the sea ice. So the darker color, that's open water. Up here, see the speckles, so much open water. Look at this. And then further north, look at this. And the space between the pieces of ice is getting bigger. So just because this is kind of spreading out does not mean bigger extent. They count it like that, but that's not the case. And here's the North Pole. Now I'm going to show you yesterday. Look, this was clear for viewing. See all the way down. Look at this opening up on this east side. Look at all of that. I mean, they probably got a lot of expeditions started up there with the sorry state of this sea ice. Look at this. Now we're looking through a little cloud, but not much. And you can see the open water between the pieces of ice. So this is latent heat that's keeping the water at 0 degrees as the ice is melting. Look at this, see? And then up here, so here's the North Pole, and just to the right there's a little spot that's open, and see our zippers, they're twirling today. See, maybe something special is happening. And then here's the ice. Look at this. That is just unmistakable. And look up here, see, where you don't have clouds, to see all that open water, the dark blue, where it's melted in between the pieces is just really, really shocking. And you can see the further we go out towards the edge, see it starts spreading out more. See, look at that. And this goes all the way up. And right here is the 80-degree north latitude line. So all of this is inside 80 degrees. It's, and I mean, this is distinctly open here. And that's at 89 degrees. And North Pole is 90 degrees. And we can look here on the west side. See, we've got evidence of the ice coming apart here. See? There's so many clouds, we have to just really pay attention. Here's a big hole. And so on. So it's all melting up there. Let's go back to today. And let's go back. Okay. Here's Greenland. And here's what's left on this east side of the Baffin Bay. Not a lot. There's Svalbard, that's open. That's free and clear. Here's Franz Josef Land. And I would say this is pretty much free and clear. And then up here, here's Severny Zemlya. Here's Komsomolets, and it's right around this island is where we see the methane out of control on cams. And this is an extraordinary view today. Look at this ice cap shrinking. And they're all shrinking. Here's the Vogelov ice cap. And see the darker? That's where the ice is flowing into the ocean. And this edge of ice, I'm thinking it's as a result of the ice flowing into the ocean. And here's this opening. There's Tamir. And then come around, here's the Laptev Sea. That looks pretty open to me. So we've got a lot of clouds and some smoke here that we're having to deal with. Let's go back. Okay, here's a good view on the 22nd. See. Look at that. How open that is. It's open on the southern end of Siberian Islands, almost around the whole thing. Just a little bit of ice right there. This green, that's algae growing. And so come on around and look at this weird melt right around Wrangell Island. It's almost a perfect circle that we see here. So I don't understand that. And here's Alaska. There's the Bering Strait. Look at that. And coming up now, we have a lot of open water here. Then the coastline. That's okay. We're on the 24th. So this is the Beaufort Sea, and here again, see the open water. That part melts first, and then as the ice cubes melt, everything shifts. And here's the coastline. Here's a big hole. See? And coming on around. And so on. Here's Ellesmere Island. Look at this. Yeah, I'm very interested in watching this melting. This is the Northwest Passage here in Canada. Look at the cracks. As it's changing states, you know, it goes through all these different colors too. Look at how this is cracking up. See, this will be flowing before long. Here's a lot of open water. And so on. So there's that. Now we're going to go to earthquakes next. We're going to take a peek at earthquakes. And there are 181 right now worldwide. I already showed the Greenland and the one just off the Juan de Fuca plate. And I'm going to go one day, 2.5% magnitude. So let's zoom in here. And here in the South Pacific, it's a 5.4 Ternate, Indonesia. Here's a 5.1 south of Kermadec Islands. 5.0 Vanuatu. Here's Japan. Here's Kamchatka. And here, next to the Juan de Fuca plate, 4.0, and so on. Alright, now let's turn on 7 days on magnitudes. See what we've got. 1,709 earthquakes this week. Now we saw one at Svalbard last Sunday. I think that's about to come off the map. see all of these? Mainly 4s and 5s is what we're seeing. Uh-oh, I didn't mean to do that. And now we'll finish up by reading out of the Bible, or the Apocrypha as it is. And we're reading out of the Book of Wisdom. This book was written by King Solomon. Wisdom chapter 11. She prospered their works in the hand of the holy prophet. They went through the wilderness that was not inhabited, and pitched tents in places where they lay no way. They stood against their enemies and were avenged of their adversaries. When they were thirsty, they called upon thee, and water was given them out of the flinty rock, and their thirst was quenched out of the hard stone. For by what things their enemies were punished, by the same they in their need were benefited. For instead of a perpetual running river troubled with foul blood, for a manifest reproof of that commandment whereby the infants were slain, thou gavest unto them abundance of water by a means which they hoped not for, declaring that by thirst then how thou hadst punished their adversaries. For when they were tried, albeit but in mercy chastised, they knew how the ungodly were judged in wrath and tormented, thirsting in another manner than the just. For these thou didst admonish and try as a father, but the other as a severe king thou didst condemn and punish. Whether they were absent or present, they were vexed alike, for a double grief came upon them, and a groaning for the remembrance of things past. For when they heard by their own punishments the other to be benefited, they had some feeling of the Lord. For whom they respected with scorn, when he was long before thrown out at the casting forth of the infants, him in the end, when they saw what came to pass, they admired. But for the foolish devices of their wickedness, wherewith being deceived they worshipped serpents void of reason, and vile beasts, thou didst send a multitude of unreasonable beasts upon them for vengeance, that they might know that wherewithal a man sinneth, by the same also shall he be punished. For thy almighty hand, that made the world of matter without form, wanted not means to send among them a multitude of bears or fierce lions, or unknown wild beasts full of rage, newly created, breathing out either a fiery vapor or filthy scents of scattered smoke, or shooting horrible sparkles out of their eyes, whereof not only the harm might dispatch them at once, but also the terrible sight utterly destroy them. Yea, and without these might they have fallen down with one blast, being persecuted of vengeance, and scattered abroad through the breadth of thy power. And thou hast ordained all things in measure, and number and weight, for thou canst shew thy great strength at all times when thou wilt, and who may withstand the power of thine arm. For the whole world before thee is as a little grain of the balance, yea, as a drop of the morning dew that falleth down upon the earth. But thou hast mercy upon us, for thou canst do all things, and winkest at the sins of men, because they should amend. But thou lovest all the things that are, and abhorrest nothing which thou hast made, for never wouldst thou have made anything if thou hadst hated it. And how could anything have endured if it had not been thy will, or been preserved if not called by thee? But thou sparest all, for they are thine, O Lord, thou lover of souls. Wisdom chapter 11. So, I just recommend that everyone get right with God and Jesus, give your life to Jesus Christ, and get under the protection of the Almighty, the wing of the Almighty God, because without that, it's going to be hard to, you're not going to be able to discern, you're not going to be protected, and your soul won't be protected. Your soul won't be protected. And that's the most important thing, is your soul. So, I love you all, and I'm praying for you. Hope everyone has as good a week as you can. And until next time, God bless you. Go in peace, and I will talk to you soon. Good night.